Alright, so we are going to look at the factor theorem. First thing, real quick, make sure that we know the difference between a factor and a zero. So let's say that we have f of x equals x squared plus 3x minus 4. Regular old pretty little quadratic. This function factors into x plus 4 and x minus 1. So we have the standard form and then the factored form of this quadratic. It's called the factored form because each one of these is a factor of the quadratic. So x plus 4 is what we call a factor. If we set the factor equal to 0 and solve the little linear equation that we came up with, then we get x equals negative 4. This is a 0 or a root of the function. So the difference between a factor and a 0 or a root. Now, why is that relevant? We are going to talk about the factor theorem, which comes in handy when we are trying to find all the factors or all of the zeros of higher ordered polynomials. So with a quadratic, I can just factor it or use quadratic formula or something like that. If I have a polynomial raised to the 5th power, that's not really an option anymore. So the factor theorem is helpful in that it tells me if x minus c is a factor of some polynomial, let's say f of x. If x minus c is a factor, then f of c is equal to 0. So it says exactly, essentially what we just showed. So if x minus c is the factor, f of c equals 0. So c is the 0 or the root. Now this is the nice little mathematical definition, and it goes the other way. If f of c is equal to 0, then x minus c is a factor of f of x. So fancy mathematical talk, what does that actually mean and how does it help us? So we already know that x plus 4 is a factor of this quadratic. Let's pretend for a second we didn't, and I wanted to know, is x plus 4 a factor of this quadratic? So that's what I want to know. Is x plus 4 a factor of f of x? So the factor theorem tells us that we can set this factor equal to 0 and solve, which we already did. We got x equals negative 4. And we can just plug it into the function. So I'm going to find f of negative 4. If it equals to 0, then I know negative 4 is a 0 or a root, and x plus 4 is a factor. So let's go ahead and plug negative 4 into that original function. Negative 4 squared plus 3 times negative 4 minus 4. Negative 4 squared is 16. 3 times negative 4 is negative 12 minus 4. 16 minus 12 is 4, and 4 minus 4, is equal, you can't see any of that, is equal to 0. So since when we plugged in negative 4, I got 0, we know negative 4, x equals negative 4, is a 0, and x plus 4 is a factor. Ta-da. Let's try another one. I want to know, we'll still use our same function. Let's come back up. I have f of x equals x squared plus 3x minus 4, and I want to know, is x minus 2 a factor? Well, using the factor theorem, I can solve this for x, so x minus 2 equals 0, so x is equal to positive 2, and plug it in, so f of 2. So I get 2 squared plus 3 times 2 minus 4. So I get 4 plus 6 minus 4, which is 10 minus 4, which is 6. So I know f of 2 is equal to 6. Since it's not equal to 0, since f of 2 is not equal to 0, I know that x minus 2 is not a factor. factor theorem.